From the smartphone that's probably in your hand right now to the most advanced medical implants, there is a hidden material revolution making it all happen. And here's a hint, it's not metal and it's not plastic. We're talking about advanced ceramics, the real unsung heroes behind our most extreme tech. So let's dive in and break down what makes these materials so incredibly special.
So to really get why we even need these things, you got to start with the problem. I mean, look at our usual go-to materials, right? Metals and plastics. They're fantastic up to a point, but they all have a kind of Achilles heel. You throw intense heat, nasty chemicals, or just extreme pressure at them, and they just give up. Metals rust, they bend, plastics, they melt, they just fall apart. And when you're building next-gen tech, that's just not going to fly. All right, so when our everyday materials just hit a brick wall, the hunt is on for something better, something way tougher, way more resilient. We need a material that actually thrives where everything else would just be destroyed.
And that's where advanced ceramics come in. Now, I know what you're thinking. Pottery, dinner plates, right? Nope, you gotta throw that idea out the window. These are inorganic, non-metallic solids, sure, but they are engineered down to the last molecule. We're talking about materials born from superfine powders and forged in insane heat to get properties that are, honestly, they're pretty much superhuman. So what are these superpowers? Well, for starters, we're talking extreme hardness and strength. These things can literally shrug off temperatures of like 1700 degrees Celsius. That's hot enough to turn most metals into a puddle. They're almost completely immune to chemical attacks and corrosion, and they're amazing electrical insulators. But, okay, there's always a catch, right? And it's a big one. They can be really brittle. See, a metal will bend, but a ceramic under the wrong kind of force, it can just shatter. Okay, so advanced ceramics isn't just one thing. It's a whole family of materials, a whole arsenal, really, and each one has its own special talent. So let's meet a few of the superstars.
First step, you've got Alumina. Just think of this one as the ultimate workhorse. Its biggest claim to fame is its incredible resistance to wear and tear. It's perfect for something like, say, the ball in a hip replacement that has to spin millions and millions of times without ever wearing down.
Then we've got zirconia. Okay, this one is really special. Remember how I said ceramics are brittle? Well, zirconia is the exception. It's uniquely tough. It has this wild, microscopic self-healing trick where it actually stops cracks from spreading. It's pretty amazing, and it's why you see it in everything from medical implants to super heavy-duty industrial parts.
All right, next up, hydroxyapatite. Now, this stuff isn't just biocompatible, meaning the body accepts it, it's bioactive. And why is that? Because it's basically the same mineral that makes up our own bones and teeth. So your body doesn't see it as some foreign object, it sees it as a framework to grow on. It's a total game changer for things like bone grafts or coatings on dental implants.
And you can't forget silicon carbide. This stuff is just off the charts, hard and strong. And the craziest part is, it keeps that strength even at ridiculously high temperatures. That makes it essential for some of the toughest jobs you can imagine. I mean, think about it. The same kind of material that you'd find in a rocket nozzle is also used to make the ultra-precise components for manufacturing our computer chips. That's some serious range.
So, you've met the players, but this isn't just lab theory. These materials are out there, right now, solving huge problems in two of the most important fields imaginable, our own bodies and the computer chips that run, well, everything. Let's talk about medicine first. Bioceramics are, and I mean this literally, rebuilding us from the inside out. They're fixing parts of the human body we used to think were impossible to repair, all because they can work with our own biology, not against it. And this is where it starts to feel like sci-fi. So picture this. Someone's missing a big piece of bone, maybe from an accident. What do? Well, today, doctors can take a 3D scan of that gap, design a custom implant to fit it perfectly, and then 3D print a porous scaffold out of a material like hydroxyapatite. Then they place it inside the body, and your own bone cells start to move in, using that scaffold as a template to grow new, real bone. It's incredible. It's guided bone growth happening right inside you. And you see these applications everywhere. Those super smooth, long-lasting ball joints in hip and knee replacements, that's Alumina and Zirconia. Dental implants that actually fuse to your jaw, that's hydroxyapatite. Even the amazing tech inside cochlear implants that can restore hearing, the tiny electronics are protected by specialized ceramics. Okay, so that's the human body. Now let's switch gears and talk about the tech that powers our entire digital world. And here's a wild thought for you. Every single computer chip on this planet exists in part thanks to advanced ceramics. And the reason why? It's because making a computer chip is a surprisingly violent, hostile process. And this is really the key to it all. To make a chip, you have to use these chambers filled with superheated, supercorrosive plasma gas. It's what's used to literally etch billions of microscopic circuits onto a silicon wafer. I mean, no metal, no plastic could possibly survive in there. But ceramics? They're right at home. So you'll find them lining those plasma chambers, basically acting as a shield for all the expensive equipment. They're used to make these things called electrostatic chucks, which grip the silicon wafers with insane precision. And even after the chip is finished, it's often sealed up inside a little ceramic package to protect all that delicate circuitry from moisture and air for, like, decades.
Look, ceramics are clearly essential already, but believe it or not, the real revolution is just now getting started. So let's take a look at the future, because where this is all going, it's honestly pretty mind-bending.
Which brings us right back to that fundamental challenge, doesn't it? We have this incredible, super hard, super resilient material, but how in the world do you actually make anything with it? You can't just carve it up like a block of metal. Trying to machine it the old-fashioned way is painfully slow, crazy expensive, and sometimes just impossible. So what do?
The answer? You don't. You don't machine it at all. You grow it, layer by tiny layer. The future of high-performance ceramics is additive manufacturing. You probably know it better as 3D printing.
And yeah, this changes absolutely everything. With 3D printing, engineers can now design these wild, complex shapes, internal cooling channels, intricate lattice structures that were literally impossible to manufacture before. This is the tech that makes those personalized, custom medical implants a reality. We can even print composites, like a metal part with a ceramic skeleton inside, getting the best properties of both materials in one piece. And the innovation isn't stopping with just printing. Scientists are now working on things like ceramic nanocomposites, basically mixing materials at the atomic scale to get brand new properties we've never seen before. They're also developing these bioactive coatings you can just spray onto a normal metal implant to help it fight infection and bond better with the body. Okay, so we've seen some pretty amazing stuff. Let's pull it all together. What does this invisible revolution really mean? Why should you care? So here are the 3 big things to take away. First, advanced ceramics are the ultimate heroes for extreme environments. They're the material we call on when literally nothing else can survive. Second, so many of our most critical technologies, from medicine to electronics, would be totally impossible without them. They are a fundamental building block of the modern world. And third, the future is all about printing. Additive manufacturing is unlocking a whole new level of design, letting us build a future with parts that are stronger, smarter, and more durable than we ever thought possible. I mean, think about it. They've already completely changed the game in medicine and computing. So the big question you have to ask yourself is, as we get even better at designing and printing with these incredible materials, what impossible problem are they going to solve next?